Hey everyone, I'm building an entire first-person shooter game from scratch in the Godot engine and documenting the progress with these tutorials. In this video, we're creating our state machine and state scripts and testing our idle to walking state transition. The basic FPS controller project from episode 1 is available for free on GitHub, and if you would like to use the written version of this tutorial or download all of the source files, you can get access by joining my Patreon. Let's dive in. There are different ways to create a finite state machine when making a game, and in this example, we are going to be using a node system. Why? That's best answered by what a state machine actually is. So far, all of our player code logic is sitting in our player script, which isn't terrible so far, but we've barely scratched the surface in what we want our controller to do. Enter state machines. A state machine is a way to organize, really categorize your gameplay logic. In this tutorial, we are creating two states, one for when the player is idle and another for when they are walking. We categorize our movement logic into two separate scripts called states, and a main state machine script then handles the logic of what state the player is currently in and how to transition into another state. The benefit is that the core logic of moving between states is handled by one generic script. All we need then are individual state scripts that detail what to do when we enter or exit a state and during each frame. Our main logic will look like this, a group of basic nodes. A state machine parent that will handle transitioning between its children nodes or our states. Naming conventions do exist, and generally you will name your state machine like player state machine, and then the children will be named with their unique state plus player state. The first script we'll need is a generic state script. This will outline what every unique state will need. We'll also set a class name so any further state like idle or walking will use our state script as a base. We then need to create our own signal that we'll use to communicate between our state machine script and our state scripts, then 4 generic functions to handle different actions we want when we transition to a state. Enter, exit, update, which is our process function, or every frame, and physics update, or our physics process. These are just placeholders to set the default functions for every state we create in the future, and they can be empty. With our generic state script complete, we can create our state machine logic. We'll need to create a new script called statemachine.gd. This will actually be attached to our parent state machine node over here. The main purpose of this script is to determine which states are loaded, i.e. what children nodes exists, what the current state is, and then call on the 4 functions we created in our state script whenever a new state is loaded. First, we create a new class for our state machine and 2 variables. An export variable to set our initial state and states, which will be a dictionary variable that will hold any state that is a child of our state machine. For example, we have idle and walking. Then our state variable will have a reference to idle and walking. Next, in our ready function, we cycle through the child nodes, check if that child is in our state class, in other words, if it has a state script attached. If true, we add our child state to our states dictionary. We can also add a warning if we find a node that is in a state. Then we enter the current state we set in our export variable. Our process functions are pretty simple. They just call on the parallel functions we created in our state script in whatever our current state is. The core logic is in our onChild transition function. In it, we get a state name being passed as a parameter, set a new state variable to the state that matches in our dictionary of the states we compiled in our ready function. If we find the state in our dictionary, which we should unless we mess up a name somewhere, we then check if it isn't already the state that we're in currently. If it is a different state, we call our exit function on our current state, call the enter function on our new state, then set our current state to our new state. This process ensures a couple things. We can control what happens whenever we enter and exit a state, and we are never in more than one state at a time, at least in this particular state machine. Finally, we add this line in our ready function so that we connect the signal we created in our state script to our onChild transition function. These 2 scripts, state machine and state, handle the majority of the logic of moving between states. Now we can be more creative in the how and the when. Now that we're thinking about our states, it's important to plan how the states interact because it will determine how we categorize them in our state machine, or if they're going to need their own separate state machine. For now, we're sticking to a one state machine and we're wanting to move between idle and walking. We're going to determine which state we are in by our velocity. Basically, if our velocity is 0, then we're idle. If it's not 0, then we're walking. With our core state machine logic in place, let's create a new script for our idle player state node. This script will extend our state class and we'll give it its own class name. We're testing whether our player has any velocity and we'll want to check that every frame, so we'll use the update function that we created earlier. Now we need a reference to our player scene and script, and there are a couple ways that we can go about it. You can create an export variable within your state script and select the reference in the editor, but you'll have to do that for every state, which is kind of a pain. Or, like we did in our last debug episode, add a global variable reference to our player so we can just call it from anywhere. Back in my global script, I'll just add a player variable, then in my ready function of my player controller script, I'll set global.player to self. So when the game loads, it will set my global variable to my player controller and I can reference it from anywhere. Back in my idle player state script, we can then check if global.player.velocity.length is greater than 0. And if it is, we emit our transition signal with our walking player state as our parameter. This will call on the transition function we created in our state machine script, exit our idle state, and enter our walking state. The beauty is that this one line is the only thing that needs to be called to handle that logic. We can decide how and when we call it, but don't need to worry about resetting booleans or a bunch of if statements. Unfortunately, we don't have a walking state script yet, so let's create one for the other child node. The same process applies. Create a class name, which is the same as our node name, extend state, then an update function where we'll create a way to return back to our idle state. If our velocity length equals 0, then transition to idle player state. We can now also set our default state in our state machine to idle. With our states and state machine ready, we should be moving between our states when we run our scene. To check that for now, since we aren't altering any movement speed or animations yet, let's use our global debug script from our debug episode. You can check that out in the description to show our current state in the debug panel. In our state machine, we'll add this line here to add the current state property to the debug panel and check our current state. When you run your scene, you should now see the current state change when you move and stop. This, of course, is just a basic setup and we'll need to better define what walking is because right now when we jump, it thinks we're walking. So in the next episode, we're going to nail down our walking state and add some basic animations before adding more states. All right, guys, if this tutorial was helpful, consider a like and subscribe to the channel as we're going to be covering a lot more. Thanks to all of my patrons who keep this series going. You too can get access to the written tutorials and the project source files by joining my Patreon. You can download everything there, and you'll also get early access to my videos and sneak peeks at future tutorials. Thanks for watching, and as always, keep creating.